Electrical safety is very important. Before discussing electrical safety, it's first important to know how electricity works. Current flows from a generating source through conductors to a load. Generating sources include batteries, portable generators, and electric utility supplies. The normal route for electricity is through conductors. Shock occurs when the body becomes a part of the electrical circuit. Electric shock occurs when current enters the body at one point and exits at another. Shock occurs when you touch both wires of an electric circuit, one wire of an energized circuit, and ground, or a metallic part that is hot. The severity of shock depends on the amount of current, the path of the current, and the amount of time exposed. Effects range from a tingle to cardiac arrest, severe burns, and probable death. At 5 milliamps, or 0.005 amps, a GFCI will trip. At 20 milliamps, or 0.02 amps, muscle contraction occurs. At 100 milliamps, or 1/10 of an amp, your heart stops beating. Severe burns occur at 900 milliamps, or 0.9 amps. Typical household current can cause death. Grounding protects you from electric shock, safeguards against fire, and protects electrical equipment from damage. At construction sites, the most common electrical hazard is the ground fault electric shock. A ground fault occurs when a hot electrical wire contacts a ground enclosure. In most situations, the fault will trip a circuit breaker or blow a fuse. However, if a break in the ground wire occurs, the worker would no longer be protected unless a secondary safety measure is available. The use of a ground fault circuit interrupter, or GFCI, is one method to overcome ground and insulation deficiencies. A GFCI is a fast-acting circuit breaker that senses small imbalances in the circuit caused by current leakage to ground and in a fraction of a second shuts off the electricity. GFCIs monitor the current to the load for leakage to ground. When this leakage exceeds 5 milliamps, the GFCI interrupts the current. OSHA requires either GFCIs at the job site or an assured grounding conductor program. At Willmar Electric Service, we use both methods of protection. Willmar Electric Service's Assured Grounding Program is an inspection program covering all cord sets, receptacles that are not part of the permanent wiring structure, and equipment connected by cord and plug. OSHA requires a written description of the program. This written description can be found in the Safety Reference Job on Procore. In addition, assured grounding procedures and color coding can be found in the Safety Reference Job on Procore. All employees have access to the Safety Reference Job. Equipment must be visually inspected for damage and defects before each day's use. The test must be performed before the first use of new equipment, after suspected damage to equipment, and at 3-month intervals. When testing tools and equipment, an assured grounding log must be completed and submitted by a competent person who knows how to correctly test the tools and equipment. Once submitted, all assured grounding logs are stored digitally to the job using Procore. The assured grounding log must be conducted and submitted every 3 months. The assured grounding log can be found in the Safety Reference Job on Procore. Once tested, tools and equipment should be taped the appropriate color to let others know that they have been tested. Tape tools and equipment white for January through March, green for April through June, red for July through September, and orange for October through December. To test a GFCI, plug a light or tool into the outlet. The light should be on or the tool should work. Then press the test button on the GFCI. The GFCI's reset button should pop out and the light should go out or the tool shouldn't work. If the reset button pops out but the light does not go out or the tool still works, the GFCI is improperly wired. If the reset button does not pop out, the GFCI is defective and should be replaced. If the GFCI is functioning properly and the light goes out or the tool stops working, press the reset button to restore power to the outlet. To test extension cords and equipment, use a multimeter. If the conductive path is broken, the multimeter will not beep or read something other than 0. Visually inspect extension cords for external defects such as deformed or missing prongs, insulating damage, indications of possible internal damage, cracked or cut jackets, loose or bent prongs, and melted cord caps. Test grounding conductors on male and female ends of cords for continuity by using a multimeter on the ohm setting. There should be continuity. The multimeter should beep and read 0. Test the grounding conductor on either end of the cord for continuity with the hot and neutral conductors. There should be no continuity. Test hot conductor for continuity with neutral conductor. There should be no continuity. Test hot conductor on male side of cord for continuity with hot conductor on female side of cord. There should be continuity. If there is no continuity, the hot and neutral conductors on one side of the cord are reversed and need to be fixed. Test grounding conductor on tools and equipment for continuity by using a multimeter on the ohm setting. Place one probe of the multimeter on the tool or equipment ground prong and the other end on metal inside or on the tool. There should be continuity. For double insulated tools and equipment, visually inspect for external defects such as deformed or missing prongs, insulation damage, and indications of possible damage. If equipment is damaged or defective, let your supervisor or the safety director know. Remove the equipment from service so that nobody else uses the equipment. Entrances to areas with live electrical parts must be marked with warning signs. Signs should forbid entrance except by qualified persons. At Willmar Electric Service, foremen have laminated energized equipment sheets that are applied to the fronts of panels and equipment after they are energized. The laminated sheets have the foreman's name and phone number on them. If ground prongs are missing from tools and equipment that are not double insulated or extension cords, cut the end of the cord to ensure that nobody else uses the tool or extension cord. Let your supervisor or the safety director know. The shops in each region are able to put new cord ends on tools and extension cords. OSHA allows the use of electrical tape to cover superficial damage to cord jackets. There is no prohibition against putting electrical tape over these kinds of abrasions and nicks when there is 1. No damage beyond the jacket, 2. The conductors have not been scraped or exposed, and 3. The insulation inside the jacket has not been displaced or compressed. While taping these incidental abrasions and cuts does not violate any OSHA standard, OSHA does not recommend it for 2 reasons. 1. Applying electrical tape that is too thick or applying too much of it could change the cord's original flexibility and lead to internal damage. And 2. The depth of abrasions and cuts cannot be monitored to see if they get worse without removing the tape. Extension cords are rated for use, and only hard or extra hard surface extension cords can be used on construction job sites. Examples of hard surface types include ST, SO, STO, SJ, SJO, SJT, and SJTO. Extension cords must be durably marked with one of the hard or extra hard surface designation letters, size, and number of conductors. Do not use light-duty cord on construction job sites. Remove cords from receptacles by pulling on the plug, not the cord. High bay temporary lighting must have caging on all sides. If there is no cage on the bottom of the light, let your supervisor or the safety director know, and the light will be fixed by adding chicken wire to the bottom of the light. If you are working under unguarded energized overhead lines, the clearance distance is 10 feet for voltages of 50 kilovolts or less. The clearance distance is 10 feet plus 4 inches for every 10 kilovolts greater than 50 kilovolts. An easier way to remember this is add 5 feet for every 150 kilovolts over 50 kilovolts. Aluminum ladders are not allowed to be used at Willmar Electric Service. Only non-conductive fiberglass ladders are allowed to be used. Circuit protective devices automatically limit or shut off current flow during a ground fault, an overload, or a short circuit. Fuses and circuit breakers are examples of circuit protective devices. If a circuit breaker trips and de-energizes the machine you are using, it must be determined that it would be safe to re-energize the circuit before the circuit breaker can be reset.